This section is all about Qt objects, and we're going to start with a quick review of Qt object because it is the base class for everything Qt, and then I have parentheses, non-template classes, and we can even put in here also not QString and a few other little classes as well. But basically almost everything Qt is going to use Qt objects. So let's go ahead and dive in here. We've covered a lot of this before, so there's no need to just really slow things down. I'm going to make two of them. I'm going to say cat Qt object, make sure it's Qt object and the Qt object macro. Next, finish. And let's go ahead and add another one here. And let's call this dog. Qt object and the Qt object macro. Let's go ahead and next, finish. Now, at the time of this recording, of course, the Qt Creator IDE does not automatically add this to our CMake list, so we have to do it. That may change in the future. Really not a big deal, just some people are going to go, well, why doesn't it do it for me? Well, development isn't always about doing it for you, although I will tell you, if you go out on Google and you type in the words CMake automatically add files, you'll find there's a little snippet of code you can copy and paste in here that will do it automatically, but I would encourage you not to do that because it will suck in every single source code file in that directory. All right, we've got two objects. We've got cat and dog, and they're just standard Qt objects. We've done nothing to them. So in our dog, we're going to go ahead and add a signal. I'm going to say void bark because, well, dogs have a tendency to bark. And then we're going to add in a slot. Now, this is where people get confused and go, well, wait a minute, there's no little area for a slot. Where do I add it? You got to add it yourself, and it's really not that big of a deal. So we're just going to say public slots. We haven't really talked about encapsulation too much, but that's what we're talking about. This is the public section. Signals by default are automatically public. And then we have public slots, and this is the private section. We could also, if we wanted to, make our own private section. This goes into encapsulation. Basically, when it's private, only the class will see it. If it's public, everything out in the world will see it. All right, so for our slot, I'm going to say void chase. And we can go ahead and just include qdebug. And let's right click our slot, and we're going to go to refactor and add definition in dog CPP. And I'm going to say, all right, qinfo chasing. And we want to get the sender object. We want to know who actually emitted the signal that made the dog chase it. So quick recap, in case that one broke your brain a little bit, we have a dog Qt object. Qt object is created by inheriting Qt object, and you must have the Qt object macro. That does a bunch of things, but basically it disables copy, disables move, and it allows for signals and slots. Signals, you don't have to implement it, or I should say you can't even implement it, where a slot, you have to implement it because a slot is actually a function that Qt goes in with mock and adds a bunch of stuff in the background. Now in our implementation for the slot, we're going to say we are chasing, and then we're going to chase whatever object triggered this. And we could, almost should, say something like this. If not sender, then return. Basically, if there's no sender, we don't even want to try to run this because, again, you can call this like a normal function. So, yeah, you got to be a little careful there. Now, we could comment this out just to see what happens if it's not in there. All right, now in our main, let's go ahead and let's include our dog. I'm going to say dog, and let's call dog set object name. You don't actually have to do this. I just like to do this so if I have objects, I can really show what they are. Let's call this Fido. I'm never good at picking dog names. I don't know why. So for dog, I'm just going to go dog.chase. You notice how it has that little icon, and I'm going to mouse down to children just so you can see the icon looks like a little outlet that you can plug into. That means it's a slot, but we can call it just like a function. Save, run. Let's see what this looks like. And sure enough, chasing object at hex 0, meaning there is no object. That's what I mean by you can test for the sender to see who actually emitted the signal that triggered the slot. In this case, there wasn't one, so it's going to be at 0. I'm going to say nothing was emitted. We're just calling it like a normal function. Now, let's go ahead and look at our cat. So we're going to say cat signal, let's say void run, because cats like to run. And now we're going to say public slots. And in case someone asks, no, it doesn't really matter where you place this. You could put your slots above your signals, whatever you wanted to do, simply doesn't matter. And then we're going to say, all right, so in the slot, I'm going to say void startled. Or shocked, or, stunned, or whatever we want to do. Or we could just say scared. Why not? Scared sounds better. Scaredy cat, get it? All right, so we're going to refactor, add definition into the cat. And if the cat is scared, we are going to simply emit the run signal. And you can name this anything you want. You can say like running, is running, whatever you wanted to do, but just follow some sort of standard naming convention, whatever you decide to do. Let's go ahead and give this a build just to make sure we didn't collide with any special keywords and we got a good build, so everything should be good to go. Let's go into our main. And I'm going to include the cat. And let's go back in here real quick. I just want to add some goodness so we can see what's going on under the hood. So I'm going to include qdebug. And then in our cat, I'm going to say info scared running for my life. Because cats just do this at 2 in the morning for no reason. Now you notice we are emitting the signal. So anything that's connected to this signal will trigger a slot on the receiver. And in that case, it's going to be our dog. So when the cat runs, the dog's going to chase it. So we're going to say, just grab these. I missed an H there. That would present a little bit of problem. So cat, and then you need a good name for a cat. How about Ghost? Why not? Always wanted a cat named Ghost. So we have a cat, we have our dog. Now we're going to just simply connect these up. So it doesn't matter if we take the actual object or if we say Q object. Connect. And then we need a sender. The sender in this case is going to be which one do we want to do? You notice how each one has a signal and slot. So we're going to say when the dog barks, we want to scare that cat. So let's jump in here and we're going to say the sender is the dog. The signal we're going to emit is the dog bark. Get rid of those parentheses. Now the receiver in this case is going to be the cat. And the slot is going to be the cat, not cot, cat scared. Now, special note, because these are on the same thread, I can just use the Q auto connection. I don't have to worry about a connection type. We covered that briefly, and that's really, really covered in the intermediate and advanced courses when we talk about threading. Now, I'm going to do the actual opposite of this, and I can actually just grab this and say, so when the cat runs, the dog is going to chase. Now, if you're ever kind of at this point and you forget what you had, just simply hit Control Space on the keyboard and it'll bring up all the properties for that object, and you can see the little icon denotes that's a slot. So we're just going to double click that. Unfortunately, it does add that little bracket in there. You just get rid of that. All right, now that we have this, well, we can try some things. Now, this is one of the stumbling blocks of QObject. Everything's wired up and ready to go, but if I run this, you notice the dog's chasing nothing. Okay, well, let's get rid of that. This becomes the chicken or the egg problem. How do we fire off that initial signal? Well, let's try a few things. Let's just experiment and play around. So I'm going to say emit, and we want to say cat dot, what did we want to do here? No, let's emit the dog bark. Let's see if we can emit it this way. And sure enough, the cat is scared, running for my life, and the dog is going to chase this cat named Ghost. So this is one of the real complexities here that you got to understand is emit is a special keyword used for Qt object, but it doesn't have to necessarily be in a Qt object. Notice we're in our main function, and we can, of course, where's my cat, emit it inside the Qt object itself. Which brings us all the way around back to how does all of this magically happen? Well, macros and mock. So let's dive out to our hard drive real quick and see what was created here. So we've got our source code and then our build directory. And in our build directory, if we go in here, you'll see all this stuff. And if we jump into these files, it's basically going to point us right back into here. And voila, these are the files that were created. And if we just crack one of these open, this is the code that Qt has generated for us. And it makes all that magic happen. All right, this video we talk about Qt types. Now, this is something that if you're an old school C++ programmer and you've worked on multiple operating systems, you know is just infuriating. Not every operating system treats integers the same way. They have different sizes, and this gets crazy frustrating, especially in embedded systems. So what we're talking about here is how Qt makes integers universal, meaning they use this special magic in the background called a typedef. I know, modern technology, right? So if you've worked with C++ before, you know a typedef is basically just like making an alias for something. So anything in Qt starts with the letter Q. And we're going to say Q, int, and you notice this pops up. If it doesn't, you can press Control Space on the keyboard, and you have some options starting with int 8. And let's just call this value 8 equals, and we're just going to null these out. I shouldn't say null. We're going to zero those out just to initialize them. We've got 8, 16, 32, 64. All right, so this is just crazy simple. Now, one thing I should note is while I'm filling this out here is there is another one, and it's not one that you're readily going to think about, but it's qint PTR, short for pointer, which does exactly what you think it would. It's just for a pointer. Just going to zero that out just to initialize it. And then just going to say qinfo. And I want the value of 8. All right, and let's just do the magic copy and paste, do this. So we've got 8, 16, 32, 64. And again, on most modern computers, you're really not going to care, admittedly, unless you really got that upper limit of that data type. But when you get into embedded, this is just amazing. Because now, it doesn't matter where you take your code, it will always be the same size. So I'm going to do the size of do a little bit of surgery here. And it doesn't matter where you run this simple little example. These will always be this size. That's one thing that Qt basically promises to you is that if you're using their typed version of integers, they're always going to be a consistent size, so you don't have to worry about if you're on this OS, make it this size, otherwise use this other data type and then make your own type defs. Let's go ahead and take a look at dates and times. So why? Because, well, just about everything uses a date and time at some point. Let's go ahead and let's do some include. So I'm going to include Q date. This is what I love about Qt. It's very intuitive. You just put the letter Q and then whatever you want, and usually that's the name of the class. So for example, if I want time, I would do include Q time. Now there is a third class I want to touch on, which is a combination of date and time. Of course, that would be named date time. I'm going to include Q date time. All of those do exactly what they sound like they do. So let's drop in here and let's examine the Q date. We'll call this today, and we want to go Q date, and our initial value is going to be the current date. Again, I would love to go into a lengthy 4-hour-long conversation about this, but it's just very simple the way this works. Now that we've got today, let's go ahead and pump that out in a Q info. Keyboard's not helping me out today for some reason. You ever have just one of those days where no matter how you try to type, your keyboard's just like, nope, not today. All right, let's save and run here. And you can see there is a current date. Now, if you're from the United States and you're not used to programming, this may look really bizarre because we're used to the opposite. This is the year, the month, and the day. We're used to here in the States, the day, month, year. Let's go ahead and close that. Now let's say we wanted to change that. We could just simply say dot add days. You notice how you have add days, add months, add years. They all do exactly what they sound like. So we're going to say add days, and we're going to add 1 day. You could, special note, do a negative number to go backwards in time, but I'm going to just do a positive number and go forward. So I want to know what tomorrow's date is. Save and run. And tomorrow will be 2021, March 4th. Pretty cool the way that works. It's just extremely easy to work with. And we can, of course, if we wanted to, let's go ahead and add years. And let's add, what is the date 20 years from now? 20 years from now, I should be like resting peacefully on my couch watching Days of Our Lives. But anyways, it will be 2041, March 3rd. So it's very easy to manipulate using the QDate class. Now, special note, we can also format this. You notice how I kind of nitpicked about how it was in the wrong format? So there's a few different formats, and this is, and I'm going to put it here, different than Qt5. So special note there. They have changed this, so if you're running Qt5 code and you're trying to migrate, this is something that's going to be different. I'm going to say Qt info, and I want the ISO date. This is just a date format, but we're going to say today, and we want toString. And notice how we can do a Qt date format. So I'm going to say Qt date format, and then we have some options here: ISO with milliseconds, RFC, and text. So I'm just going to do ISO date, and I'm going to do each one of these just so you can see the differences here. And let's go with the RFC date. I'm not going to do the ISO milliseconds. And then let's go with the text date. Save, run. Let's see what this looks like here. So our ISO date is, well, what we've been working with. The RFC date is this, and the text version is this. And there's other ways to expand upon that. Again, we're just kind of hitting at a very high level what you can do with this bad boy. Now, that being said, I want to put out, if my notes will cooperate with me here, the Qt5 version of this. This is what you would do for Qt5. That's kind of gone the way of the dinosaur. There's no system local date anymore. They kind of prefer the ISO date. Now, from here, we can just say, let's work with QTime. So I'm going to say QTime now equals Q time, and you're going to see a definite pattern here because it's very, very similar. Current time. And then from here, you guessed it, it's shockingly similar. We can do just about anything we want to do. We could say like now, and then you can add milliseconds, add seconds, things like that. You can get the minute, the seconds, and all this other stuff, to string, from string, all these great things are baked right into here. Now you notice how it's add seconds. There's no add minutes or add hours. So you gotta be a little careful there. But we can take this, just copy this, and just show you just how easy this is. We're gonna swap that variable out. And there you go. There's the time. So we got the ISO. I should change that to ISO time, RFC time, and the text date. This is actually pretty cool, but it's also ridiculously easy is the point I'm really driving home here. So let's just look at this and say Qt, and we can do like a time. See if there's a time format. You'll notice there is no time format. So you're a little bit limited, but you can really do this in any way you want. The main fundamental point here, though, is that it is ridiculously easy. Now, let's just go ahead and dive into the Q date time. And let's call this current. And this is going to be, you guessed it, the Q date time. And we want the current date time. I'm going to scroll down a smidge here, get some screen real estate. Now that we've got this, it's, well, you guessed it, just ridiculously easy to work with. I'm just going to Qinfo this out and say, what is the current? So this is, well, quite boring, unfortunately. So let's spice things up a little bit here. What I want to do is make a new Q date time. Let's call this expire. And this is going to be the current date time. And we're going to add 45 days. So think of this like a software limitation. You ever get like that, what is it called, shareware, where you have to buy it within 45 days or something like that. I think usually it's 30 days, but that's basically what we're doing here. Is we're going to check to see when this actually expires. So let's go Qinfo. And we're going to expire on this date. Let's save and run, and let's see this in action here. So we're going to expire 45 days from now, and you notice the date is, well, 45 days from the date of this recording. And it also gives me the time and the time zone that I'm actually in, and this is our local time. Notice how when I did date formats, it wasn't coming up with a time format, but there are other things you can work with here is the point I'm trying to make. So if you want an expanded version, you would look at like the Qt local time. That being said, all of that's in the documentation, so I'm not going to have a lengthy conversation about that. You can just quite simply go on to anything you want, press F1, and it's all right there in the documentation. And it's very, very lengthy documentation because, as you might guess, dates and times get very, very complex very, very quickly. And you can format these in any variety or array that you really want. I mean, the sky's the limit on what you want to do. Now, that being said, toString is probably going to be the most famous thing you're going to work with, and you want a string format if you want any custom formatting whatsoever, and then you have to give it the custom format codes. All right, now back to our expiration example. Let's do some simple logic here. So we're going to say if the current is greater than the expiration date, well, you guessed it. We need to tell the user, you are expired. Please buy our software or do whatever it is was supposed to happen. Then we can just simply go otherwise, or in this case, else. We want to let them know that, hey, this is not expired. So let's go ahead, save, run, and let's see. Ah, not expired. Thank goodness I get to keep using this awesome program. This video, we're going to look at QString. So take out the letter Q. Really what we're talking about here is just a string. This is Qt's universal string class, and this thing is, well, amazing. If you ever had to work with raw strings before, they are frustrating. QString makes it ridiculously simple. You don't even have to include anything because it's baked right into Qcore. So I'm going to just simply say QString, and let's say name, and then type whatever your name is. We've done this before. We've been doing this throughout this whole course. That's how simple it is. Now I'm going to say QInfo, and of course, let's just print this out. Go ahead and run this. Now, the really cool thing about this is QInfo is smart enough to say, hey, this is a QString, so it's going to put quotes around it. So whenever you see something in quotes, 99% of the time, it's a QString. Let's go ahead and close that. Makes it ridiculously simple to work with. Now, let's just play around with this a little bit. We're going to grab this, and I'm going to say, I want to know what's within a range, but it's actually called mid. And it's got a starting position, so I'm just going to say 1, and an ending position, I'll say 3. Now, this is a zero-based array. So 0, 1, so the letter R, and then 2, 3, and so on and so on. So let's see what mid returns between 1 and 3. RYA, and of course, if your name is different, it will be different. And if your name was much shorter than that, then you may have had other issues. So let's just demonstrate what would happen if it was shorter. Notice how it automatically trims it out. It just goes right to the end, and there's no error, no crash, nothing bad like that. So now that we've got that, let's try inserting something. So because we know this is basically just a zero-based index or zero-based array, let's go ahead and say, you know what? Dot, and then insert. We have a position, and I'm going to say 0, which is the very beginning, and then I want to just insert another string. Now you have some options here. You can do byte arrays, const char pointers, QStrings, string views, and things like that. So what do we want to put? Well, depending on who you are, just do something like this. I'm going to put Mr. and space. Doesn't really matter. Just make sure there's a space at the end here for this next little example. Let's save run. Now let's see what that looks like here. So now it's going to be Mr. Brian Cairns. I feel really weird when people call me Mr. I feel like really old. I don't know why, but anyways, let's go ahead and grab this. And now I want to split that up. So what split does is you can take a character of some kind, and I'm going to use the space, and it will return different strings. So it's going to read through that thing and split it up, a lot like splitting up firewood. So now it's going to return a Q list, something we haven't really talked about in depth, but just ignore the letter Q. We're talking about a list of Q strings. So there's Mr., Brian, and Karen. So we've got 3 distinct different strings here. Notice how the space is magically gone. That is, well, actually pretty darn cool. You can do some sophisticated things with QString with very, very little effort. So let's say we want to find the position of, or the index within that little array. It's actually a list, but let's see if we want to find the position of it. So I'm going to say int. Let's call this index equals, and we want to do the name dot index of, and we need to tell it what we're looking for. Now, index of is a little bit funny. If we press F1 on here, you can see how it's going to do a Q type size. And this is what is a little bit confusing. Returns the index position of the first occurrence of the string, searching forward from the index position from returns -1 if not found. What does all that mean? You can actually define, and of course they've got documentation on how to do it right here. You can define where to even start, but it's going to return the position or -1 if not found. You can also do case sensitivity and all of this other stuff. It's all baked right into the documentation, so I'm not going to spend hours and hours talking about it. All of this information is literally right at your fingertips. So now I can just simply say, if index greater than -1, then I can go ahead and do something with that. So I'm going to say QInfo And I want to do name.remove. And what we're going to do here is we're going to say we want to remove from the starting position 0 to where we found it +1. The +1 is the length of the space here. So I'm just going to chop out this Mr. dot and then space. And just because I'm not sure if I'm really good at math, I'm not sure if a space is 1 character or 1,000, I'm going to say, you know what? Just to be safe, let's just do trimmed. So what trim's going to do is just take a knife to it and trim off all that white space. White space are non-printable characters. Go ahead, save, run, see what this looks like here. And sure enough, it's converted it back to Brian Cairns. Very, very cool. And if we omit this +1, you'll see it says dot space Brian Cairns. So now we've got this little guy here. So, yes, I did make a mistake. And the mistake was that I forgot we were looking for the period, not the space. This is the tricky part of index of. Sometimes you can deceive yourself. Now, if I were looking for just the space, what is it going to do? It's going to jump that ahead because it's going to stop where it found it. And instead, it will jump over here. Seems a little confusing until you run it and then you see it in action. And voila. The space is not there because, you guessed it, we use this little trimmed right here. That is extremely cool, extremely powerful. Now what we can do is something like this. We can just say qstring title equal teacher. Let's get some screen real estate here. And we can make more qstrings here. So we can say qstring full, and full is going to be the name plus. We're just going to concatenate or add those together. So we're literally just taking 2 different Q strings, technically 3, and adding them all together. And then we can just simply say Q info and print that out. There you go. Now you notice we've got this little guy back here again, so that's a problem. What we can do now is trim that. So save, run, and it strips it out before adding it all together. That is, well, beyond powerful compared to other things that you've probably worked with. So then go Q info and 2, you notice how when you type the word 2, you can actually convert this to a lot of different things. And obviously consult the documentation for what you want, but there is a number of things you can do. Now, one thing that I like to do is to UTF-8. Why? Because most of the world is running on UTF-8. If you don't know what that is, UTF is a representation of data. So we used to have ASCII, and then we moved to UTF-8. There's also other higher versions of that. And basically, this is like, when you talk about UTF, you're talking about every printable character in the known universe. This is extremely powerful, so now you can support other languages. It's baked right into Qt. So if you had Japanese or Korean characters or something like that, they would be baked right in there. Now, last thing before we wrap this up, we're going to make a function, and we're just going to simply say qinfo name. Notice what we're doing here. We have something that starts with a Q, and we're making a copy, and I'm going to put that right here. You may be screaming, no, wait, you can't copy. Well, QString is not a Q object. It's really not. So you can copy that to your heart's content. Now let's go ahead and do the full. And just demonstrate. Notice how we don't get any warnings, we don't get any issues, and we can just save and run, and it works as expected. Major takeaway here is that QString is, well, extremely powerful. It has UTF baked right into it, and it's the universal string class for Qt. You can do all sorts of string manipulation, and it's actually very quick, and you can copy it. It gets way more complex than that because it is the universal string class. As you can imagine, the documentation for this is, well, staggering. There's a lot of documentation here. But 9 times out of 10, if you're looking to figure out how to do something, just scroll all the way down into the detailed description, read about it, and then you can actually get some source code examples baked right in the documentation on how to do pretty much just about everything. Sometimes when you're working on something, you get a little frustrated and you got to bring out what I call the big tool. There's always like this toolbox and you have this one tool where you're like, I'm done asking, we're just going to do it. That is the QByte array. This is a must-have class for working with data. So at its, well, core, no pun intended because we're talking about Qt core, QByte array is pretty much the universal class for anything data related. And you'll see what I mean here in just a second. So let's say QString, which we've worked with before. Let's call this greeting, and let's go ahead and just do the obligatory hello world. I mean, we're right back at the very beginning of this tutorial. Let's say we want to do stuff with that, but you know what? QString's just obnoxious. It's a great universal string class, but we want to work with data. So I'm going to say QByte array, and let's call this buffer. So we're working on some kind of application and we are knee deep in data and we want a buffer to work with. I'm going to say greeting dot, and from here we can say 2. And when we start looking at this, like if we go to Latin 1, to local 8-bit, you notice the return type here, QByte array, and so on and so on. Even if we say to UTF-8, we get a QByte array. So this is extremely cool. We have QByte array baked into even the most fundamental universal classes. So we're really getting down to the nitty-gritty here. So now that we've got our buffer, we want to try and do something with it. Well, it's actually very simple. Dot, and you notice how we have append. So let's just try it. And we have a whole bunch of things that we can append here, including other QByte arrays and QByte array views and things of that nature. So let's just go ahead and let's append something. And let's QInfo it out, much in the manner we would a QString, or pretty much any other data type. And hello world. This is extremely cool. I mean, it's so simple to work with, and a lot of languages and frameworks and things like that working with, well, bytes is a royal pain. But this just, again, I'd love to turn this into a 4-hour lesson. It's so simple. Why bother? So I'm gonna say buffer dot, and let's go ahead and right justify this, which is going to take everything and justify it off to the right. Very, very self-explanatory. And I want to give it a special character. Now notice it's a character, so a string isn't going to work. I have to use single quotes. And we're going to do that with just a period. Let me get rid of that annoying yellow box there. And let's print that out and see what that looks like. Ta-da! It just works. I don't have to screw around with any crazy documentation or special function calls or anything like that. It just works. I love that. All right, so let's grab this thing. And let's say we want to know what's at a specific position in our buffer. So I'm going to say at. Again, very, very self-explanatory. And now we need a position. Okay, so this is a zero-based thing. So I'm going to go buffer.length, which is going to give us the length of the buffer. But because this is zero-based, I need to -1. So it's going to give us the very last thing in the buffer. Let's go ahead, save, run, see what this looks like. Our last thing is, well, an exclamation point. Ta-da! Very cool, very easy to use. And we can also interchangeably work with other things. Let me demonstrate. So QString, our beloved QString, let's call this modified. And we're going to use the constructor of QString. And you notice there's a couple things we can do in the constructor, including use a QByte array. This is just great. So now what I'm showing you here is you can take a string, turn it into a QByte array, manipulate it, and then put it back into a string. And it is just awesome. I mean, it's really hard to describe unless you've had some real world experience in other languages and other frameworks. Let's go modified. It's actually taking me longer to type it out than it is to actually understand how all this works together. But when you run this, you can see the modified version is, well, very easy. Very simple, very elegant, right down to earth, and it doesn't take a genius to figure this out. We can also do some basic encoding and decoding. Notice the words here, basic, encoding, and decoding. So this is very, very basic. And encoding and decoding is not encryption. Repeat that after me. It is not encryption. But we can say Q, info, buffer. And in case you are wondering how you would encrypt something, at this point in time, you really do need to use a third-party class. There are some things built into Qt, but they're more advanced than what we're talking about. And they're not what I would use as industry standard. You're going to want to use some sort of third-party library. So anyways, back to encoding and decoding. So we can take this buffer and base 64 encode it. We could also take this buffer and do a 2 hex. So if you want to see what it looks like in hex, you could see that as well. Ta-da! Very simple, very easy to use. And again, just to sound boring and repetitious, all of this is baked right into, you guessed it, the help system. Simply highlight it, press F1, and all of the documentation is right at your fingertips. This video, we're going to talk about Q variant. So what is a variant? Well, it's an unknown type, or I should say a variant is a wrapper around an unknown type. It's part of the meta system. Remember when we talked about mock and the meta object compiler? This is Qt putting data on top of data. It's called metadata. So really what we're doing here is we're wrapping around data so Qt knows what it is. Let's go ahead and demonstrate here. We need to include Q variant. So right off the bat, notice I've got Q variant include right here. We can simply take that and say Q variant. Let's call this value. And then give it some kind of value. Notice I didn't say integer or double or anything like that. And I can say Q variant, and let's call this value 2. And let's go ahead and say hello world. Notice what's happening here. We have two radically different types of data, an integer and a string. But we haven't declared them, and we're not using templates. We're just saying Q variant. So we're letting Qt take this and wrap something around it. And that wraparound is called the Q variant class. This is, well, an incredibly powerful class. And if you hit F1 and start digging through this documentation, your mind's going to be just spinning with ideas because this is way, way powerful. And when you start getting into things like QML or the Qt's newer way of displaying a graphic user interface, it's heavily used under the hood. It's just they hide a lot of that complexity behind QML. But there's also something else you can do that's incredibly cool with it. So we're going to say void test and Q variant. And let's call this value. There we go. Almost made a major boo-boo. Notice what we are doing. We're making a copy. So this is copy friendly. So this is not a Q object. So let's try doing this. We're going to work with some sort of unknown type of data here. So I'm going to say Q info value. I just want to know what I'm working with. Now, from down here, let's call that. And let's call with our value. It's going to do a copy. And then let's call this with our value 2. It's going to do a copy. And let's see what we got. So it's smart enough to know that this is an integer and this is a string, although we didn't declare the types. That's exactly what Q variant is doing under the hood. This is way powerful when you think about it in terms of, well, you can do just about anything with it. Now, it does have some limitations. The biggest limitation, which I'm going to touch on right now, is that because you can basically wrap around a data type, it's up to you to figure out what to do with that data type. Okay, let's figure this out. So let's go ahead and say int, and let's call this I equals 0. And let's say bool, OK equal false. So what we're going to do here is we're going to see if we can convert this into an integer. Notice what I just said. We're going to see if we can convert it into an integer because both of these are wrapped in a Q variant. So they're no longer an integer or a string. It's a Q variant. So we need to take this Q variant and see if we can convert it. So what we do here is we say I equals, and we want to do a value dot 2. And when you type 2, here's pretty much a list of all the things you can try to convert to. There's a lot of things. So what are we trying to convert to? We're trying to convert to an int. Notice how in the definition, it's going to return pointer, letting us know what happened here, whether it's good or bad. So what we're going to do here is we're going to say, oh, all right. Go ahead, grab this. Now, notice I said it's going to return, but actually what we're doing is we're letting it modify that for us. And then we are going to pass that by reference, not by value. That way, you guessed it, we get that information back. So it's returned to us and we can work with it. So if OK. So now we have a bool that tells us whether or not it succeeded in converting that. We can say qinfo. And I want to know, this is now an int, and we have that data. Otherwise, what we could do is something like this. Else qinfo not a number. Probably should say not an int. But yes, you may have guessed if the initial data type was like a double or something like that, you are going to have data loss because it's going to cast it in the background for us. Let's go ahead and save run and see this in action. So the first one is going to say int1. The second one, which is obviously a Q string, is going to say not an int. This is way powerful and it touches on a lot more than we could possibly cover in this course. Q variant is used very heavily when you get into QML, which is much more advanced and goes way out of scope of this course. But yes, you can, and probably there are times you should use Q variant to pass data back and forth. Let's talk about the Q string list. Now, this is a funny name. It's kind of combining two things we've heard of, strings and lists. And it is exactly what it says. It's a list of strings. Note, these are not arrays. We've highlighted arrays very early on in this course, and I personally hate arrays. When I said there's a much better way, we're talking about lists or containers. Now, we're going to talk about QString list because it's so flexible and it does exactly what it says it does. So I'm going to take QString list. Just grab this. Let's go down here and let's say QString. And let's say data equals, and let's just give it some sort of string. Hello world, how are you? So what do we have here is just a simple sentence. Okay. Now I want to make a QString list. Let's call this LST. I'm going to say data.split. Remember our old split function from our QString video. And you notice it's returning a QString list. So all we're really going to do here is give it a separator here, and I'm going to say, okay, separate that by the space. So what it's doing in the background is it's looking at the string. It's saying, oh, here's a string, 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 and it's ignoring that separator, and then it's returning a list of those strings. So now instead of one variable, you have one variable that contains 1, 2, 3, 4, 5 different strings. This is wow, powerful. I mean, I absolutely love that. So we're going to say LST, and let's QInfo that out, see what it looks like. And sure enough, you notice this is the confusion right here, Q list. I thought we were working with the Q string. This is a little bit confusing. What's happening under the hood is, well, QStringList and QList are slightly different in previous versions, and they've been kind of merging things towards each other. So if we click that and highlight it, see the QStringList class provides a list of strings, inherits from QList strings. So there is a template going on here, is what I'm trying to drive home. If you need something other than a string list, use QList and then provide the data type. We'll talk about QList a little bit more later on, but understand what's going on here is QStringList is inheriting that. That's why fundamentally it looks different when you try to print it out. From there, we can do something like this. For each, and then we want to know for each QString, call this str, and this is going to be in our list. I just want to print out each individual string. So I'm going to say QInfo. And let's go ahead, save and run and see that in action. And it's got each individual string. Hello world, how are you? And you know they're individual strings because there's quotes surrounding each and every one of them. So that is a very easy way to break a string apart into a usable list of some kind. Now let's say we want to do something like sort it. So I'm going to say lst.sort, and we're going to say Qt, and we want the case insensitive. You could have done sensitive, but you're going to get a different result than me. And then I'm going to say, let's just grab this. And run it. See what this does now. So now it is sorted case insensitive, R, hello, how, world, you. Completely different. So now you can manipulate the data inside the list. This is very, very cool. Now, let's say we want to know if we can find a specific instance of something. So I'm going to say QString myvar, you can call this whatever you want, and we're looking for the word hello. You can just simply say if lst dot, and then narrow that down to contains, and we want to know if it contains that right there. If it does, well, all this contains is going to do is return a bool. So now I want to find the actual position. So I'm going to say int, let's call this index equal lst dot index of, because remember this is a zero-based index. And I myself have slipped up many times and said this is a zero-based array. And then people go, I thought you said it was an array. It's not, it's a container, but it's a zero-based container. And then we're just going to say myvar, because we want to know where that is, and we'll get the actual position. And then we can just, if we wanted to, say, oh, okay, so lst dot the value, and it wants to know the location here. So then we can just give it the index. And in case you're wondering, yes, we could have condensed that all down basically to one line, but I'm really breaking it down just to show you each individual command. We've got contains, index of, and value at a specific index. Save, run, see what that looks like. Ta-da! Hello. Now, spoiler alert, index of is going to return a -1 if there's no index. So we probably should have done another if statement right here. When in doubt, you can just simply go into the documentation and, of course, just thumb your way through there. There's a lot of it. There's a lot more than what we've covered. So all of QList functionality also applies to QStringList. So if you're ever concerned about what you can do, just hop into QList, and there is just a metric ton of documentation on QList because it is kind of Qt's de facto container. And you can do virtually anything you can think of with this. It's just awesome. Let's talk about QList. What is it? Well, it's a templated container class, and that's also why we need to cover it, because it's a template. You can put anything into it. It's a container, so you put other things into it as a class. All right, let's dive in and take a look here. So I'm going to reuse our QString from a previous video, and I'm going to say QList. Notice how we have to do a type name. Oh, okay, so we need to, you guessed it, define a data type because this is a template. So I'm going to put a QString in here, call this list, and we want to take that QString and let's go ahead and split that. Now, remember from the previous video, QString list is really inheriting QList, so we can actually use these virtually interchangeably. This is pretty powerful. You may be wondering what's the difference between a QString list and a QList of strings. Well, a QString list has a bit more string functionality, where a QList is just a templated container. All right, so now that we've got that, let's go ahead and say we want to do something like, let's go for each QString word, and we want to know that in our list. Ta-da! It's very, very simple. Let's go ahead and save run. And it, of course, split it off, and we've got all that data in there. It's very simple, very easy to use. Now, let's go ahead and show something a little bit different. So I'm going to say QList, and let's go ahead and say we want to put ints in there. If I can actually spell the word int. There we go. Apparently, I'm challenged today. So what I'm going to do here is I'm going to use the constructor, and I'm going to use some brackets, and just show how we can very quickly, very, very easily build this up. There we go. It is literally that simple. You can also, if you wanted to, append. So I'm going to go ahead and append. Let's say I need a good number, 99. Notice it's a string. So if I try to append that, let's see what's going to happen here. No matching function call, because this is a template. It knows the data type we're supposed to be working with. So it really saves us before we even attempt to compile here, which makes it just great. And we can also say age.remove. Now, this is where it gets a little confusing. You see, there's a bunch of removes. So we can remove basically at a position. We can remove all occurrences of something. We can remove at a specific position, remove the first occurrence, the last occurrence, or only one. Wow, that's nuts. So let's go ahead and remove. And let's try removing. Now, this is where the confusing bit comes in. We saw all those removes. What does this one really do? So I'm going to highlight this and press F1. Removes n elements from the list starting at the position. Oh, so here's our n, automatically 1. So this is the position. So let's say I want to get rid of 56, which is at the first position. Now we've got some basic manipulation. That's one thing I just absolutely love about the built-in help system there. So I'm just going to QInfo this out. And let's go ahead and say age. Now let's see what that looks like. Save run. And sure enough, it's gone. So now we've got our 44, 21, 13, and 99. And it is wrapped in a nice, neat little queue list that's super, super simple to work with. Now, a lot of this class and the classes that we're showing in this section go way beyond beginner's land, and we really cover these in depth in our intermediate and advanced course. So if it seems like we're really just scratching the surface, you're absolutely right. And it's because Qt just gets so complex. You can do just about anything you want to do with it, so you got to be a little bit careful here. Now, that being said, I don't want to dissuade you from diving into the help system and checking things out on your own. If there's something that we're not doing in these videos and you need to know how to do it, your first stop should be, you guessed it, to highlight the class in question and press F1 and dive right into the help system. Let's talk about QVector. Well, this is confusing, so forgive me in advance if this sounds confusing because it is confusing. What we have here is just some simple code, and we've actually done this before in the previous videos. We have a string, a QList. Notice we're talking about QVector. And of course, QList is a templated container which can take different data types. So what is QVector? Well, in the past, notice I said the past, QVector and QList were two different container classes that did very similar but different things in different ways, and there was a almost religious holy war about which one you should actually be using. That is all changed in Qt6, and now QVector is an alias for QList. Let's go ahead and demonstrate. So we got this code, save and run, and it's the same code that we've worked with before, just very simple, demonstrates that we have a container. We can just simply swap this out. QVector, and save, run. Let's see this thing in action. See, just works. Now, let's go ahead and try something a little different. Notice this is a QList of strings. Let's try a QVector of strings. Let's go ahead and run, and it works, but on the surface, it really shouldn't, because QVector and QList in the past were two different classes. And when you do the data split, notice that's returning a QString list, which of course is an alias for QList of strings. So by proxy here, QVector of strings is the same thing as saying a QList of strings, which is the same thing as saying a QString list. Like I said, if it sounds confusing, it's because it is confusing. Really, what we're talking about is over time, Qt has refined things more and more and more. And as they're doing it, they're finding that the overlap they used to have between things like QVector and QList are no longer needed, and they've pretty much just merged them into one and said QVector is an alias for QList. And what this really means is that any code that's out there that uses QVector isn't going to magically stop working. It will just continue working like it did before, but now under the hood, it's all using QList. Okay, that makes more sense. So that solves the age-old argument of what should you be using, QVector or QList? Well, the answer, of course, is either. They're both the same thing now. I almost always use QList because, well, it's shorter than typing out QVector. And now they do the exact same thing, where in the past, QVector did things slightly faster than QList. And honestly, when I say slightly faster, most mere mortals never would have noticed the difference. This video, we're going to talk about QMap. And I'm going to have to break this video up into little bitty sections here because it does get a little bit complex. So what is QMap? Well, it provides a key value pair. And the reason, the description sounds really, really confusing. The QMap class is a template class that provides an associative array. Wait, what? Did you get all that? So if we look at QMap, really fundamentally, what are we talking about here? Again, you can just take the word, press F1, takes you right to the documentation. This is a template class, much like QList, but it has a key and a value. Think of it this way. People have names. Every person, an object, has a name or a key. That's really what we're talking about here. So let's dive in and let's take a look and see what it takes to work with QMap. So first thing we're going to do here is we're going to get rid of that because it's going to cause an error. And we're just going to very, very quickly, we're going to make a class called pet because we're going to put a bunch of Q objects inside of this container. So we're going to say add new, class, and pet. Again, you can do whatever you want to do. You don't necessarily have to make a pet class. I'm just using it as an example. Let's go ahead and add this in super quick. And because this specific video is about QMake, I'm not going to spend a lot of time talking about the various parts of the class. And to be brutally honest, it's ridiculously simple anyways. So I'm going to say, I want a few private things here. So let's go ahead and say int m age and qstring m name. And then if we wanted to, very quickly, all we have to do is right-click Refactor and then add the getters and setters for each one. Makes life ridiculously simple. Now we have built-in encapsulation for our private variables. That way we are not letting the outside world modify those directly. All right, so if you have any more questions or comments or concerns about encapsulation, just think of it this way. We have this variable and it is private to our class. We don't want the outside world to be able to set it without us knowing about it. And if they go ahead and get it, we want to be able to tell them what it is in a specific manner. We don't want to rely on C++ to try to cast it for us or anything like that. So that's really what we're talking about, is encapsulation or protecting our little class here. But that's it. We're not going to make this class super complex. I just wanted to show you that we can do things with it. Very simple. We have an age, we have a name, we're inheriting QObject, we have the QObject macro, so this is officially now a QObject. Make sure we save that, and let's give it a good build just to make sure we don't have any little gremlins lurking in our code waiting to bite us. All right, we're good to go. Okay, the last section, all we did was create this pet class. It's super simple. Feel free to pause the video if you skipped over that, but it's just a QObject with an age and a name, and we have getters and setters for both. From here, we're going to do two things. We're going to go ahead and include our class. So I'm going to say pet.h. And I honestly, I hate type defs, but they do have their place. I'm just going to say they are fun. They're really not fun for me, but we're going to make a type def. And this is something that I hear people go, what does type def mean? Basically, you can take a complex type and give it a super easy to remember name. For example, we're going to say we want a QMap. QMap can be pretty complex looking. It's a template class, so we have to include these brackets. We're going to say QString is the key, and we want to use a pet pointer as the value. So now we have a key value pair. The difference being we can give it some sort of name like Fluffy or pet number 99, and it will know the value of that is the pointer to this object out on the heap somewhere. But we don't want to type this every single time we want to work with this. So instead, we're just going to call this pet list. So when we are coding away, instead of retyping all of this craziness, we can just simply type pet list, and C++ knows this is what we're talking about. That is the beautiful and yet maddening part of type def. Just in case you're skipping around this video, quick recap. We have a QObject called pet, and we've made a type def to a QMap with a key that is a QString and a value that is a pointer to a pet. And we've called this pet list. Now we're going to create that map. Let's go ahead and show how this works. So I'm going to say pet list. Remember, we're using a type def, which under the hood translates to this whole jumble mess, QMap, QString, pet. So we're going to say this is going to return a pet list, and let's say create pets int max. So we're going to have a maximum number of pets we can create. And let's go ahead and say pet list map, and then for int I equals 0. Forgive my horrible spelling. I is less than max, then I plus plus, so we're going to just increment that. Now from here, it's actually pretty straightforward. I'm just going to say QString ID equals, and this is going to be our key, say QString. We want to convert this QString into a string from a number, basically. So we're taking an int and converting it into a QString. So we're going to give it the value of I. In case you're confused what's going on here, it's right here, int I. So we're just saying from our for loop, go ahead and make an ID. And that is going to be a string because that's what our key needs to be. If we try to just hand that over, C++ is going to say, I don't know how to convert this, and it's going to not compile at all. So now we want a pointer to a pet. And we need to say pet equals new. Caution, whenever you use the new keyword, what are we doing here? We are creating something out in memory. And we're doing this on the heap. So I'm going to put notice the possible memory leak. Always know what you're doing with memory. Yes, you absolutely could have passed a pointer or the address of this Qt application and set the parent if you wanted to. But we're not going to. We're going to live a little dangerously. And you see I've got just a bajillion warnings popping up on the screen at this point of C++ saying, are you sure you want to do this? Potential leak, potential this, potential that. All right. We're going to just move on, and we're going to be brave here. And all these warnings can just set aside for a moment. Now that we've got our pet, I'm going to say pet, and we're going to use the setter. I'm going to say set age. And I'm going to just pick a number here. Age I times 3 is whatever the age is going to be. Let's go ahead and say pet.setName. And I'm not going to make a bunch of random names, so I'm just going to call this pet. And then whatever the ID is. Feel free to do whatever you want to do for the name. You could call them Fuzzy Bunny Slippers 1 through 9. Doesn't really matter. Just demonstrating that we can use the setters. Now we need to take our map. And notice there's no add. There's no append. What we have to do is insert. That's the other confusing bit about the Q map. So we need to give it, because this is templated now, you notice how it knows a Q string key and then a value, which is a pointer to a pet. This is the beauty of adding a type def along with Q map. It takes all that complexity out. So now we're just going to add our key, which in this case is going to be the ID, and then our pet. Remember, because our pet is a Q object, we cannot copy. We have to give it a pointer. Always remember that. Otherwise, you're going to get that, copy disabled, and you're going to have a bad time trying to figure that out. So now we're just going to return the map. But notice what we're doing. We are copying this. There we go. I was trying to do a little exclamation there. So we can actually copy the Q map because the Q map itself is not a Q object. This is actually pretty cool. So now we have this Q map filled with these Q objects that we can just pass around. Okay, so far we've got our Q object, we've got our type def to our Q map, and we have a function that can create a Q map of pets. Now I want another function that is going to list those pets out. This is extremely simple. So I'm going to say void list pets. Not pest, pets. There we go. Sometimes our pets are pests, but anyways. So we're going to give it the pet list. Remember, this is a type def to, you guessed it, our Q map, Q string, pet pointer, which we're actually defining right up here. Remember, type def is just basically us making an alias saying whenever we call this word, really replace it with this. Saves us a little bit of typing there. Now that we've got that, let's call this pets. Before I forget, create some error, but notice what we're doing. Notice the copy. Why is copy important? Because, well, it's very error prone in regards to trying to copy Q objects. And it's also a little bit memory intensive, especially on low-end machines. That's what makes C++ so awesome, is you can work with the raw memory and just pass a pointer. Anyways, we're not going to just really worry about the speed. I'm just going to make a copy just to demonstrate we can do it. Let's say QString key, and we want the pets.keys. Notice what we're doing here. We're saying for each QString, misspelled, I'll have to fix that, but each key in the pets keys, and the keys is actually a Q list of strings. So it's a list within a list. It's actually really, really elegant the way that works. Fix that, and so now we have a list of keys. Each key is associated with a value. So you have your key value pair. So now that we have the key, we actually can get the value. So I'm going to say pet pointer. Let's call this pet equal pets dot, and we'll say value. And notice how the first thing it's saying in value is it wants the key. It needs to know what we're looking for, and that key has to be unique. So we're just going to grab that. And now I'm going to QInfo this out. So I'm going to say QInfo. And we want the key. And I want to know the pet. And let's go ahead and call the getter. I'm going to say the name. And then I want to know the age of that pet. Let's call the getter for that as well. It makes it ridiculously easy to just pass an entire map of objects that you can call by a key value pair, and it just makes it super, super easy. So, spoiler alert, next part here, we're going to actually make all of this work together. All right, what I like to do is give my application a good rebuild after I made all the functions and classes and everything to rest assured that all these components we're going to put together are going to work as expected, or at least we suspect they will. So I need to make a pet list. Remember, pet list is just a type def to something different. And that something different, let's see if it's going to work. Nope. Is a QMap string pet pointer. There we go. And let's call this pets. And we're going to call our function create pets. And we want maximum of 5 pets. So very simple, very easy to use. And I'm going to say QInfo. Let's go ahead and get the count. I want to know how many pets we actually have. And we're just going to say count. Now, this is a little bit misleading because people often see this and think, oh, I can have multiple things with the same key here. That's actually not the case. So the key denotes what the value is. And we're going to demonstrate here in a second why you shouldn't try to give the same key. But anyways, let's just run this and see how many pets we actually have. Count 5. All right, let's go ahead and list them out. Notice what we have here. All right, we have 5 of them starting with 0, 1, 2, 3, 4. These are strings. You can tell by the quotes. And sure enough, our key right here, then followed by the name, pet 0, 1, 2, 3, 4, and then the ages 0 through 12. All right, so take special note of this guy right here, 1. Notice what that is. The key is 1. We're going to replace that, and we're going to go up here. And I'm going to slow down just a smidge. And we're going to say the age is 99. The name, I need a good name here. Let's call this Bad Kitty. And we're going to go ahead and insert this with a key of my cat. And we're going to put it in the appropriate list. So really what we're doing here is we are inserting a new pet into our list. I'm going to go ahead and do list pets. And let's see what we've done. All right, so now we have 6 of them, and my cat, or Bad Kitty, is at the very end of the list. What I'm going to do is I'm going to change the key from my cat to 1, and you'll see this guy right here. Let's watch what happens. Change that key. Remember, we had 6 of them. Now we have 5. And the first one has now changed to Bad Kitty. This is what I mean by keys can get a little confusing. Keys have to be unique. Now, what just happened under the hood is we have now said, hey, Qt, use this pointer instead of the other one. And that class that we made is now just sitting off in space somewhere collecting memory. Yes, we made a memory leak. That's bad. You don't want to do that. So you're always going to have to manage the memory yourself. So I'm going to toggle the comment selection there. Oh, that is super frustrating. But that is why I use a parent-child relationship in regards to memory management, which we've not done. We're doing manual memory management. So let's talk about that real quick. What we want to do now is we want to say, okay, let's go ahead and clean up this application because we're going to shut it down. We're going to use what's called QDeleteAll. If we look at QDeleteAll, it deletes all items in a range, begin to end, using the C++ delete operator. So we can basically just say, go through this entire list and delete everything. But it must use pointers. So if I try to say pets, pets are not pointers, are they? Let's go ahead and save run. Notice how free invalid pointer. What's happening here? And you may actually not see that because under the hood, Qt's doing it a little different. Qt is going to go through, and it's smart enough to know the difference between, say, a QList or a QVector or a QString list, or you guessed it, a QMap, and it's going to find out where the pointers are, and it's going to try to free them up. Now, specifically, it crashed our app. So I'm going to say values, and this is going to return a container of, well, you guessed it, pointers to pets. So it's going to say QList, and then the type is pointers to pets. Go ahead and save run. And we still get this invalid pointer. Where's this coming from here? Well, if you look at this, the order, we're deleting those pointers and then we're trying to work with it. So you're going to get really bizarre results as we're trying to work with this, and in the background, C++ is busy deleting things. Ugh. So let's comment that out and let's see it run. Notice how it didn't crash. We have a count of 5. That's the confusing bit about delete all and working with lists or maps, is it does delete the pointer, but it doesn't delete the things out of our container. We still have 5 things in there. So whenever I do a delete all, I almost always do a clear, even if I am going to immediately exit the application, because you don't want to accidentally do something. Now we can uncomment that. And because there's no items in our list, there's no crash. It just works appropriately. Okay, major takeaways from this course and this video is that Qt is extremely awesome, and you can do some powerful things by combining Qt and C++. But you have to know how to do things the Qt way. And specifically for this video with QMap, QMap is a key value pair. Whenever you manage memory, you have to manage that memory unless you rely on Qt's memory management systems, specifically the parent-child relationship, which of course we set in the, you guessed it, the constructor of our Q objects.